question. So here you have. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3, where n is any positive integer. Where n is any positive integer. Now here you have. Let's solve the given question. Like solution. Let firstly, by using Euclid's division lemma, Euclid's division lemma, where here let it be like let n be any positive integer. So let us write down here that let n be any positive integer. Positive integer. So let this formula be like n equals to bq plus r. Okay guys, so let n equals to let n equals to bq plus r, where let n be any positive integer. So let n be any positive integer and b equals to 3. Okay, let b equals to 3. Now firstly here, as we know, where n equals to bq plus r, so n equals to b means 3, right? So 3q plus r. So where we know where Euclid's division lemma is in a form of n equals to bq plus r, where here 0 is less than or equal to r less than b, where 0 is less than or equal to r less than b value is what? 3, right? So less than 3. Therefore, the possible remainders can be what? The possible reminders can be where r is less than 3, right? So this can be 0, 1 or 2. Okay, then the possible reminders can be 0, 1 or 2. Done? 0, 1 or 2. Now firstly, let's write down reminders over here, where reminders. So the possible reminders can be 0, 1, 2. Now here, where n equals to 3q plus r. Now let's substitute this. Let's substitute these values in this given r place. Okay, just make this as 3 cases. So firstly, let me write down like this. As a question, show that one and only one out of n plus 2, n plus 4 is divisible by 3. Okay, whether it is divisible by 3 or not. They asked to show this. So to find this, first let's go for case 1. So first case, where in this first case, where if r means remainder equals to 0. Okay, if remainder equals to 0, what happens here is n equals to 3q plus 0. So 3q plus 0, so as here I can write like 3q as it is, so 3q, that's all. So 3q plus 0, here the remainder is getting 0, therefore this is divisible by 3, right? I can say that this is divisible by 3, right? So let me write down like here, where in the first case n is divisible by 3, let me write down like divisible by 3. Done. Now let's go for the next one, the second one, where if n equals n plus 2, right? So here we have done with n. So next we have what? N plus 2. So if n plus 2 equals to 3q plus, here n equals 3q, then n plus 2 becomes what? N equals 3q and n plus 3q plus 2 plus 0, right? So let 0 be 0, but here you have what? The remainder, in the place of remainder you have 3. Sorry, you have 2. So in the place of remainder you have what? 2. Therefore I can say that this is not divisible by 3, because remainder 0, if remainder is 0, then that is divisible by 3. But here we got what? The remainder is 2. So it's not divisible by 3. So let me write down like not divisible. Not divisible by 3. Done? Hope you understood. Now let's go for the next one, n plus 4. So let's go for the next one here, n plus 4. N plus 4 equals to 3q plus 4 again, where remainder is 0, right? So let it be like 3q plus 4 over here. Now the remainder we got what? 4, where n equals to 3q plus 4, where 3q plus 4, where remainder equals to what? 4, right? So therefore remainder is 4. I can say that this is not divisible by, not divisible. So this is not divisible by 3, right? We have done with the first case, case 1. Now let's go for the second case. Okay, let's use remainder as 1 in the second case, in the given second case. So here, let me clear. So if remainder is 2, guys, okay, if remainder is 1, we have done with 0, right? If remainder is 0, n is divisible by 3. Okay, 1 is divisible by 3, but the other 2 is not divisible by 3. So if the second case, case 2, in this case where r equals to 1, if r equals to 1 means remainder equals to 1, what happens? n equals to 3q plus 1. It becomes what? n equals to 3q plus 1. So here the remainder over here is 2. Oh sorry, here the remainder is 1. As here you can see the remainder over here is 1. Therefore this is not divisible. Let me write down the other one. So here this is not divisible. Divisible by, so this is not divisible by 3. Done. Now let's go for the next one. N plus 2 equals to 3q plus 1 plus 2. So here 1 plus 2 gives what? 3, right? So let's write down this the next step down, where here where n plus 2 as it is. Here 3q, 1 plus 2 gives 3, right? So 3q plus 3. Okay, here 3q plus 3. So if I divide 3 by 3, this becomes 0, right? So this becomes 0. So let me write down like here, this is divisible by 3. So let me write down like this will be divisible by 3. So yes, it's divisible. So this is divisible by 3. Now let's go for the next one. Here n plus 4. N plus 4 equals to 3q plus 1 plus 4. So 1 plus 4 gives what? 5, right? 1 plus 4 gives what? 5. So 3q plus 5. Done. So here the remainder is 5 over here, right? The remainder is what? 5. Therefore this is not divisible by 3. So therefore this is not divisible by 3. Okay, 5 in 3 times not divisible, so it's not divisible by 3. Let's go for the third case. Right, third case. So here, okay, let's take like third case. Case 3. If r equals to 1, here you can see where if r equals to 0, n is divisible. Where n is divisible by 3. Where here 3q plus 0, where 3q is divisible by 3. In the second case, you have only 1 where n plus 2 is divisible by 3. Now let's go for the third case. Where in the third case, okay, in the third case what happens here is, so when coming to the third case, where 3q, if remainder is 2. If remainder is 2, we are done with remainder. If remainder is 0, we got what? N is divisible by 3. If remainder is 1, n plus 2 is divisible by 3. Now if remainder is 2, what happens? Okay, let's make a look over here. So here if remainder is 2, n plus 3q plus 2, this becomes 3q plus 2, right? So this becomes 3q plus 2. Let me write down here. So this becomes what? 3q plus 2. So where 2 is remainder, right? So 2 is remainder, therefore this is not divisible. Because 2 is remainder, right? So 3 into times not divisible, so let it be like 2. So this is not divisible one. So we are not divisible by not divisible by 3. Let's go for the next one where n plus 2. N plus 2 where 3q plus 2 plus 2 as here 2. Okay, 2 plus 2 is what? 4, guys, right? 4. So 3q plus 4 where here let's write down like here 3q plus 2 plus 2. So 3q plus 4. So 4 can be done 3q plus 4. So this further I can write like 3q plus 1 plus 3, right? 3q plus 1 plus 3 gives 4, right? So here 3 is still divisible, but here the remainder we are getting what? 1. So therefore this is not divisible, right? So this is not divisible. Let me write down here, this is not divisible. No. Not divisible by 3, right? Now let's go for the next one. If n plus 4 equals to, if n plus 4, let me write down here. Okay, let me write down now divisible over here, as we know. Let me further write n plus 3 by 1 plus 3, right? So this is not divisible by 3. Okay, so now let's go for the next one where n plus 4. So n plus 4 equals to 3q. 3q plus, if the remainder is 2, right? 3q plus 2 plus 4. Now here 2 plus 4, 6, right? So 3q plus 6, where 3 to 6, right? So where 6 is divisible in 3 table, whereas 6 is multiple of 3. Therefore I can say that this n plus 4 equals to q plus 6. Therefore this is divisible by 3. So let me write down like here. Yes, this is divisible. Yes, this is divisible by 3. Done. Now therefore here I can say that where in the third case n plus 4 is divisible by 3. Let me conclude over here, guys, where therefore among all the equations, one only either n or n plus 2 or n plus 4 is divisible by 3. Divisible by divisible by 3. Thank you.